Welcome to X1T Gaming, and together we're going to revolutionize the gaming industry. So we're going to continue on from learning about this project doing the speedometer, and I think I got the Text Mesh Pro working. How? I have no idea. I guess that when I loaded it, when I was doing my game yesterday, and then when I loaded up the thing today, it probably corrected itself somehow. I have no idea. No clue. Don't ask me. I think it works. I'm not 100% sure it works, but like I'm looking at it and there's no like underscore saying that it's not working. So it says it's going to work. And then we're going to itemize our thing. So let's continue on where we left off, which was in 6.2. Let me refresh, make sure that I'm logged back in. And then 6.2 part 3, where we're going to add a speedometer. Okay, let's just go forward a little bit.
First, what we're going to do is with the actual text, we're going to rename this to variable for that text.
Okay, so I think I got
that
text
press play, right. We should see speed in the top left corner. Cool, so that looks pretty good. Not going to change any of the text for now. Wait. For the font.
Do I have text? Environment, we got crates. Okay, so we don't actually have text, but we have the Text Mesh Pro, which is weird. Okay, so does that mean we need to have... Okay, now I'm a little bit worried because I don't have a text.
So in the hierarchy, I'm going to right click in the empty space, go down to UI, and go to Text Mesh Pro. Since I haven't added Text Mesh Pro to this project before, I'm going to need to import it. Now that it's imported, I can exit out. So now we can see in our scene, we have our vehicle, but we can see the white outlines of this Text Mesh Pro canvas. So I'm actually going to select that canvas and press F. So now it zooms out so I can actually see very far zoomed out. So if we get our canvas in frame here, you can see our little game world here in the corner. And then we have our Text Mesh Pro canvas here. So if I press play, you should see that little new text pop up, probably on the bottom, right about there. So that doesn't look good at all. So we're going to have to actually adjust that. So first what we're going to do is with the actual text, we're going to rename this to our speedometer. And we want our speedometer to have probably a position in the top left where our player can see how fast they're going. So first I'm actually going to change the anchors to be the top left. And now I'm going to move the text over to that corner, right about there. And then for the text, I'll just say speed for now. Now if I press play, we should see speed in the top left corner. Cool, so that looks pretty good. Not going to change any of the text for now. For the fonts or anything like that, I'm just going to leave it as is. In this case, since we just want to see our speed working, we're not going to use a game manager script. I'm actually just going to use my player controller script, since that's where I can actually see the speed that our player is moving at. So in the player controller script, I actually need to create a variable for that Text Mesh Pro text. So in fact, I actually need to import that library first. So at the top of my script, I add a using statement for using TM Pro. So now I can find the Text Mesh Pro library. I'm going to create another serialized variable like this game object. This time I actually need the actual text. So I'll get the Text Mesh Pro UGUI and call it speedometer text. So now that I have this variable, in Unity I need to make sure that I actually attach this text to the speedometer text. So I'm just going to click and drag on speedometer and drop it in there. So now we have a reference and I can change the text when I need to. Now the question is, how do we actually calculate the speed of our vehicle? Once again,
Okay, let's pause that for a second. Did I forget to save? I forgot to save. Go to here. I think the speedometer needs to be in Canva. And then when we look at the red car, now we have this one right here. The speedometer should go right there. Okay, now we'll see the
we'll
Google
head
stuff.
over to the internet and see if anybody has any questions for us. So I looked up calculate vehicle speed. And one of the first answers is how to get car speed. That seems like what I'm looking for. So let's see. This person has a car that can move and they want to get the speed. Okay, so it says here, so for car speed in kilometers per hour is speed. So I guess we need a speed variable again. We set that to the magnitude. So we can actually get the velocity that our rigid body is moving. So that's very helpful. And then in this case, they multiply by 3.6. So that's a pretty good start. So we can actually just use this rigid body.velocity.magnitude. And velocity will actually get us the actual velocity, the speed that our vehicle is moving. And the magnitude gives us the number. So that was pretty helpful. I did notice as I was going through the results that there is another result about a car with wheel colliders. We do have wheel colliders, so let's just see what this person says.
Ooh, I wonder if the
Making
wheel
a simple
colliders will
car
not work
driving
on
game
mine.
with the
Because I have
GUI
that
text.
front thing.
Cool, that's exactly what we're trying to do. The speed display doesn't seem very realistic. This person has this little formula here. Let's see what the reply is. So simply get the speed by using, there's that rigid body velocity magnitude again. Oh, so it returns the speed in meters per second. So that's what you get when you're using velocity. So to get the speed in kilometers per hour, oh, so you multiply by 3.6. So that's why the 3.6 was there. If you want to get it in miles per hour, multiply by 2.237. Oh, okay. So because when you're going from meters per second to kilometers per hour, you have to do a little bit of math to get the proper number of how to convert meters per second to kilometers per hour or miles per hour. So that's actually what those numbers are. Don't need to do calculations using wheel colliders. Okay, cool. That's pretty helpful. So since it said we needed to make a speed variable before, I'm actually going to uncomment out our speed variable. I'm actually going to turn this into a serialized variable as well. Since our speed is actually being calculated now, I don't actually need to set it when I start. Now, in my update method, I probably want to calculate my speed after I apply that force. So if I do speed equals player rigid body dot velocity dot magnitude, then we want to times it by, I think it was 2.237 f. That way our program knows that that number is a float. Just for our own sake, if we want to change it to kilometers per hour. So for kilometers per hour, change 2.237 to 3.6. Okay.
Okay. So we'll put this comment for miles per hour because for miles per hour, change to 2.237 F. Let's go. And then for kilometers per hour equals 3.6 F. Okay, so I'm going to be using kilometers per hour simply because I am Canadian and that's what we use here. And if that bothers you, I am sorry. But
So
can't
now we're
go
getting
by
that actual
wrong
speed. So now we just need to actually set the text for our speedometers. So if we do speedometer text dot set text, we need to make a string so we can say that this is the speed. And then we concatenate the actual speed that we're calculating. And then just as a nice touch, we'll add another string at the end to say miles per hour. So now if I save this, hopefully, now our speed should update in the top left when we play our game. We need to make a string so we can say that this is the speed. And then we concatenate the actual speed that we're calculating. And then just as a nice touch, we'll add another string at the end to say miles per hour. So now if I save this, hopefully, now our speed should update in the top left when we play our game. Okay, well that's very weird. My speed is moving very fast. I think I actually still have my vehicle set to be very heavy. Let me change that really quick. Up 2,000, I believe it was 1,000 before. Let's see, so now we play, and we can move down the road. And there you go. So you can see it's changing. There's a lot of numbers after the decimal point. And in fact, when we press play, you can see that it actually starts giving us a number value because it's falling to the ground. So that doesn't look right. Also, it's kind of small. We should probably make that a little bit larger. But let's fix this problem first because this looks very weird. Just all these decimals. So how do we get rid of these decimals?
I wonder if you
Well, the
changed
decimals happen because this number is a float. And to get a round number, we actually need an integer. So how do we get an integer from a float? So let's head back over to the internet and see what it has to say. I looked up how to convert float to integer Unity. The first result that popped up is this mathf round to int. So returns f, so that's the float rounded to the nearest integer. Let's see. So float f, so that's the number we're passing in. And then it gives you back f rounded to the nearest integer. Okay, so it looks like this is how you would use it. So mathf.round to int, so then you put in the float, and then it gives you 10. Okay, So mathf.round to int. Well, let's see if that works on this little formula that we have here. So I'm actually just going to apply this here. So let's see, mathf.round to int. Then I guess we just want to put this entire number in here. So now if we save, so now we should just get whole numbers. There you go, just says 0. Should probably make that text box a little bigger.
Okay, that's weird. Oh, this is why. Okay. Now let's see, and now it's going pretty good. And it's going good speed, getting too fast, and yeah, you'll never see a car go that fast. What do you say? Put up the maybe I can bring down the horsepower. Maybe I can bring down the mass. Or wait, what if I up the mass to 2,000? Doesn't move. Have it at 1,000. It's moving now. What if I have, oops, at 1,500? There we go. Go super slow, granny style acceleration, and it picks up. Oh boy. Oh boy. And it stays around 70. That's too much. Too little. Let's do 200. It's 1200, I mean. Yeah, that seems like a more decent speed. Going now highway kilometers, going pretty fast. And now it's going way too fast again. I wonder how we can fix that, or if you do fix that. I don't think so. Is that it
Whole
for that?
round numbers, so that's good. So that works great. So we'll fix that issue with the size later, but that works. For a fun little fact, if you remember a few lessons ago, we were talking about different keywords you could use on variables. Things like const, read only, and static. You can actually see we have a const variable here for our turn speed. And this is actually down here, where we're calculating our speed, a case where you can actually see a static class. Actually, in fact, up here as well. And so if you remember, in cases like our rigid body, we have to actually create a variable for that rigid body and then assign it to something. But for things like input or for math, we don't actually need to instantiate anything to use these classes. That's because they're actually static. And so static allows us to use different classes without having to create an instance like player rigid body for a rigid body. So what we're going to do is in proto...
Wait, so I didn't know what that meant, but that's good. Mark as complete, and now they want the RPM display. Okay, so it's just saying for the thing you should do like the math F round, and you just do like a speed percentage of 30 times 40. Do we want to watch this one? It's 7 minutes. Let's do it. Let's do it. I'm pretty sure we've made a new one of
Another
this.
cool feature that a lot of car simulators have is a display of the RPM, or revolutions per minute. The tricky part is figuring out how to calculate it. First, what we need to do is create a new text area for our RPM. So in my canvas, if I left click on that little drop down arrow, so we have the speedometer here, I need to right click on canvas, and I'll create another UI text mesh pro. Now it's somewhere off in the distance. Let's see if we can get, there you go. So you can see it's in the center of our canvas here, and we need to actually move it to the top left, about here. I'm actually going to set the anchor first, so it's in the top left. Then let's see, what line is that at on the Y? X is 135, so I think if we just move this over, there you go, so it's all lined up, so that looks nice and clean. And here we'll change this to RPM. To avoid that problem we had with the speed before, with wrapping, we're going to set this to disabled. And now we can get our RPM. Let me make sure that I rename this element to be RPM. Now I need to actually create another variable for this. So in my player controller script, right after the speedometer text, I will create a new serialize field text mesh pro UGUI. We'll call this RPM text. And now I need to make sure that I set the RPM as a reference. So in Unity, if I select my player, I'll drop this RPM text element down into the RPM text. So now we have the RPM text, but we need to actually calculate the RPM. So let's see what we can do. So the internet will be another helpful resource here once again. So
Google Sensei.
here we need to calculate the RPM of our vehicle in Unity. So we have all of these different options. We'll check out this Unity answers question. So this person is making a speed limiter. wants to do this through wheel_collider.rpm. That could be interesting. Problem is we would have to get a reference to one of our wheel colliders and then see what that does. Let's see what this person says. If you want to get the speed, you should know the circumference of your wheel. Multiply it. Okay, let's see, what are they doing down here? Speedometer, put your wheel radius. This seems a little too complicated. We're just going to maybe do a bit simpler of a whole calculation than this, but this is a generally helpful start. You can see they're actually doing the conversions from the RPM to the speed, which is kind of cool. So in order to get our RPM, I'll make another variable, and just so we can see what it's doing, we will make it a serialized variable called float RPM. So now we actually have to do some calculations for our RPM in our update method. So that person used RPM to get to speed, so we can use our speed to get to our RPM. So we'll make our RPM variable. And RPM is generally a pretty large number compared to our actual speed. So if you're going somewhere around, I don't know, like 80 miles per hour, maybe you get like 3,000 RPM or so. So we'll just say like speed. And in this case, we'll just create our own little formula and just kind of show you a cool symbol that you can use. So if I type shift on the number 5, I get this percent symbol. And just for the sake of seeing what it looks like, so speed percent 30. So the percent symbol is a special kind of operator in C# and in programming in general, called the modulus operator, or what you may be more familiar with, the remainder operator. And so this means that we are actually dividing speed by 30, and then it will actually give us the remainder value. So if speed were to be 30, and then we divide by 30, we actually get a 0. If we divide speed, which is 31, divide that by 30, we actually get a 1. And so this is just kind of a cool way that we can kind of wrap our numbers all the way from 0 to 29. So let's save. And in fact, we actually need to set this RPM in our RPM text. So we do RPM text, set text, RPM plus RPM. So now we save. Let's check out our project, see what happens when we press play. So now we should just see it go from 0 to 29, and then it goes back. So that's cool. However, 29 is definitely not a very high RPM. So we'll make this a little bit cleaner. We'll actually just wrap this entire little equation with parentheses, so that way this operation happens first, and then we multiply this times 40. Let's save. Now let's see what kind of numbers we get. Okay. It's kind of as if, like, when you're going through each of the different speeds, you're actually kind of shifting gears in a way, resetting the RPM back down every time. Cool. So what you're going to do is create a new text object for the RPM.
Okay, that was weird. That was a little bit too easy. And this one, it says that the RPM needs a math F round, which he forgot to do. Just because we don't want to have all those crazy numbers at the bottom. And there you go. So we got our kilometers per hour and we got our RPM. Nice. Not flipping because we got the, what's it called? The center of mass, spelled with an RE because that's the correct way to spell. If you do not agree with that, please leave a comment. Okay, so we got one more, but it looks like it's going to be a long one. We'll probably do it tomorrow. Oh, it's only 8 minutes. Do I want to do it now? Getting late. Yeah, so declare a new list of wheel colliders. Name all wheels, front wheels, back wheels, then assign each of your wheels to that list of inspector. Okay, so this part I think I'm going to have a little bit of a trouble with simply because I don't have those special. Oh, I do have wheels though, but they don't have the special mesh what they have. But that's fine. Okay, we're going to call that a day. Boom. So we got the text TM Pro to work. How? I have no idea. We got all this other stuff to work. How? I don't have any idea. I got some idea. So that's interesting. How you could do stuff like that. Maybe one of these days I'm going to have to make like a car game. Yeah. Well, I have a cousin-in-law, so my wife's cousin, and he actually makes cars from scratch. It's pretty cool. Maybe I'll use his cars as an example one day. Okay, so until then, I will see you guys tomorrow at 9 p.m. Pacific.